Well, hello everybody. This is Mr. Foley again, and welcome to part two. This will be way shorter than 48 minutes, which I'm sure you looked at the time already, so I'm happy about that. So we're looking at gas laws right now. If a sample of gas occupies a volume of 75 milliliters at standard pressure, so volume equals 0.075. Remember how I hate milliliters, and I change it right away. So I suppose it could go 0.0705 liters at standard pressure. So what does standard pressure mean? Remember, this is mean. STP equals 1 atmosphere and 273 Kelvin. But this just says standard pressure. So that means, I'm going to rewrite this, make it a lot neater. So I have 0.075 liters standard, and the pressure is going to be 1 atmosphere. What volume will the gas occupy at 815 torr? So I did an atmosphere, so remember standard pressure is 760 millimeters of mercury too. Changing those units around. So what would occupy? So this is my original. V2 equals question mark. P2 equals 815. So remember P1 V1 equals P2 V2. That's Boyle's law if you need to know the name of it. And my pressure originally is 760. My volume was 0.075 liters. And it's true, it doesn't matter if you left it in milliliters in this case, but be on the safe side in case you ever have an R problem. We want to make sure that'll work. And then my new volume is 815 V2. Oh, my dog's in here saying hello with a whale. So let's see what we do. 760 times 0.075 divided by 815 is V2 equals 0.0699. Notice this is 4 sig figs. This is 3 sig figs. My answer should have 3 sig figs, and it does. And this is going to come out in liters. What will be what volume in milliliters? So now I got to milliliter this. So I move it 3 spots. 1, 2, 3. 69.9 milliliters. Remember, whenever you get an answer on your calculator, you want to check to make sure you answered the question. There you go. 15 grams of potassium chloride reacts with 12 liters of oxygen, STP. So whenever I see STP, I like to make a note that it's 1 atmosphere of pressure and 273 Kelvin. So 15 grams of potassium chloride reacts with 12 liters of oxygen to produce potassium chlorate. How much excess reagent remains in the same unit as it was given? Woof. Okay. So what that means is I'm given 15 grams of this, and I'm given 12 liters of this at STP, and I want to figure out how much of this I'm going to make. Okay. So I am going to now, I think a lot of teachers do this a different way where they convert one into the other. I convert them both into the same product. So, and then go from there. So that's what I'm going to do. 15 grams of potassium chloride, KCl, times dividing bar. 1 mole of KCl, and then grams of KCl. So potassium is 39.10 plus 35.45 for chlorine. So little g means grams, and little g means go to the periodic table. So I'm in moles of KCl, but I want to get, so I just want to point out here, the question is how much excess reagent remains. So I'm going to take a little bit of a shortcut. Normally I convert this into grams, but I'm just going to go into moles this time. So 2 moles of KCl, and then 2 moles of KClO3, and calculators assemble. 15 divided by 74.55 times 2 divided by 2 is 0.201 moles of KClO3. The other one started with 12 liters of oxygen. 12.0, right? Oh, 12. That means 2 sig figs. This is 15.0 plus 3 sig figs. So, okay, so 12 liters of oxygen times dividing bar, and then 1 mole of oxygen at STP is 22.4 liters of oxygen. And then I'm getting out of moles of oxygen. 3 moles of oxygen gives me 2 moles of KClO3. Again, we've got coefficients here. These have to equal each other, right? So 3 moles of oxygen will give me 2 moles of KClO3. And I will then do that math. 12 divided by 22.4 times 2 divided by 3 is 0.357. And that's moles of KClO3. So now that I've done that, I remember this is how much is actually made because it's smaller. And what that means is KCl is your limiting reactant. So remember, to find out how much excess you have, I'm going to convert KCl into O2, and that will tell me how much I need. Okay, I know I have 12 liters, so let's see how many liters I need. 15 grams of KCl times dividing bar 1 mole of KCl is 74.55 grams times, again, I'm converting to something else, so 2 moles of KCl and 3 moles of O2 times, my O2 is given to me in liters, so 1 mole of O2. Remember, at STP and STP only, 22.4 liters of O2. So this number should give us a number less than 12. 15 divided by 74.55 times 3 divided by 2 times 22.4. So 6.76 liters needed. Now remember, we have 12, okay? So 12 minus 6.76 is going to be 12 minus, okay, I'm being lazy here, 5.23. But remember here, notice these are no good sig fig places, right? So that means my answer is 5 liters of O2 excess. So again, tricky things from this. Remember, get rid of my, when you want to change units, moles over moles use coefficients, right? So whenever I have these, moles over moles, and that's how I change from one thing to the other, that's when I use my coefficients, okay? So, and the only way you can get from like KCl to KClO3 is using your coefficients. The other thing is to get your excess. So for your excess, you take your limiting reactant, convert it to your excess, and then subtract. All right. Identify the following for a 4.56 times 10 to the fourth molar HNO3 solution. This screams out to me, strong. So what strong means is it turns into 100% ions. So that means the OH negative, oh no. So what the first thing I thought I would see here is it's strong. So that means I have 4.56 E negative 4 molar H positive, which I thought would be the first question, but it's not. So I like to do my pHs first. Negative log 4.56 E negative 4 is going to be 3 point something. Negative log 4.56 E negative 4, enter, 3.34. That equals pH. Remember, pH equals negative log OH, and that's on that equation list that we have again. And then hopefully remember pH plus pOH equals 14. So that means 14 minus 3.34, and that's 10.65. And then it's like, oh no, the sig fig thing. Do you see how this has 3 sig figs? So if it has 3 sig figs, that means I need to have 3 decimal places. So 659. So sig fig rules, right? Okay, so if I want to get OH negative now, OH negative equals 10 to the negative POH. And then second log negative POH is 10.659. Whoops. Second log negative 10.659. I get 2.19 E negative 11. Oops. Yeah, that's 3 sig figs. So there's another way where you could do this, which would be H positive times OH negative equals 1e negative 14. And I could have done this from the start, but I don't like I don't like that one as much. I don't know why. I just don't. I'll be honest. I'm picky. I'm not a fan of that one. All right, it's not letting me scroll down. Let's see if I can scroll down now. All right, let's give myself some more room. All right, so these are the big mean math ones. I'm going to give myself a lot of room. Whoops, for the rest of these. Whoops. Okay, sketch reaction profile. What a nice little preview. Okay, these are just circle them. True, false. Gosh, we're almost done. Complete the following table. Almost. Dun, dun, dun. Okay, good. Woo, good. So here we go. 32.7 milliliters of this solution. Goodbye, my friend. I don't believe in you. 0.0327 liters of an H3PO4 solution are required to neutralize 25 milliliters of 0.015 molar NaOH. What is the concentration? Okay, so if I'm neutralizing, I use my neutralization equation. XMV equals XMV. And I just put my acid on the left and my base on the right. Remember, X is the number of H positives, and X equals the number of OH negatives. Okay, so for H3PO4, my X is 3. 3 H's. It's got to be a leading H if you've got that. The molarity is what we're looking for the acid. The volume of the acid is 0.0327. It is true you could do them both in milliliters, but again, it's always safer to use liters. And then how many OHs are in NaOH? 1. What is the molarity of NaOH? 0.015. What is the volume of it? 25 milliliters, 0.025 liters. M equals. Okay, so start on the right-hand side, 0.015 times 0.025 divided by 3 divided by 0.0327, and I get 0.00382 molar. Check my sig figs. I got 3 sig figs here. I've got 3 sig figs here, 3 sig figs here, and I got myself a right answer. I should say what it is. That's H3PO4. A synthesis reaction between A and B has an activation energy of 500 and an overall reaction energy of 200. Okay, sketch a reaction energy profile on the axes below. Be sure to label the reactants products. Okay, so overall reaction energy is plus 200. This means endo. So endothermic reactions, remember, have to end up higher. So I'm going to start right there and go, woo! Excuse me. Sorry, I should have paused. So the activation energy is 500. So I got to pick a number to start with, okay? I like to start with a nice easy number like 100. And here are my reactants. And if my overall reaction energy, I think that means the energy of the products, is 200, right? That would be up 100. And that would be positive delta H of that. Oops, that's not. Overall reaction energy of plus 200. So this depends on whether it means, okay, so that's not the energy of the products. So this right here is supposed to be 200. So these are different words than I think I would have used, but that's okay. Plus 200 here, which means this is going to have to be 300. And then the activation energy means from this spot up to here has to be plus 500. So 100 plus 500 is 600. So there you go. Sketch an energy profile on the axis below. Be sure to label the reactants. Products. EA is right here. And energy of the reaction is delta E reaction. I feel way better about that being delta E reaction. It's also often shown as delta H of the reaction. So, good. This reaction is, we talked about it already, endothermic. Heat is absorbed from the surroundings. So see how I have 100, I get up to 300. How does it do it? It absorbs it from the surroundings. So like if I have $100 and then I end up with $300, I had to absorb $300. I'm sorry, I had to absorb $200 to get there. I had to get a job. How do you do that? Do well in chemistry. Heat is, oh, my circle went away. Absorbed from. True or false? The activation energy of the reverse reaction would be larger than the forward reaction. That is false. So the activation energy on the reverse reaction would be, I'm going to change my color here to green. So my activation on this one would be, this would be the EA reverse. And that would equal from 300 to 600, 300 kilojoules. That's smaller. Complete the following table. I need a smaller looking pen because this table is tiny and my handwriting's bad. All right, get your periodic table out, my friends. Let me get myself a periodic table. Hold on. Okay, so to teach you how to do this, so the first thing I want to review is the periodic table number. So your periodic table will come in a box. My favorite element is thorium, god of thunder. So if you look at thorium, the important numbers for thorium on the periodic table I'm looking at has a 90 up here, and it has a 232.04 down below. 232.04. This right here is the atomic number, which is the exact same thing as the number of protons. What do I mean by the exact same thing? It's just like your parents and Santa Claus, no difference at all. It is usually, so I'm going to put it in quotes, the number of electrons if no charge. Okay, so I guess I put really big quotes around that, okay? This right here is the mass. Oh, this is the average mass. And I want to warn you, this is meant to trick you on this part, okay? Don't use for these tables. Okay, that's the average mass, okay? So you probably don't want the average grade of chemistry students in America. Average grade in chemistry is like a D. You want better than that, I hope. So you don't want to use that average. How do you get the mass then? Mass number, and it's called mass number, is protons plus neutrons, okay? So, wait a minute. So, when I have these symbols like this, so I have 173, ya boy, YB, I gotta find ya boy here. Ya boy is number 70. So I found it on the periodic table, and the number that I'm using is this number right here, is what I would go with, ya boy. So if you look at number 70, you'd find it there. I'm gonna put that in there because it'll make my life a little easier. So symbol is that. So let's do what we can do. Mass number is 173. But if I looked at your boy on the periodic table, your boy's got a mass number of 173.06. Notice it is not 173.06. That is very important. Don't do that. The atomic number is the bottom number. That's 70. Number of protons, always identical. Number of neutrons, so right here, mass number equals protons plus neutrons. So I have 173 minus 70 is 103. Number of electrons, notice how they're the same, so my charge is 0. Okay. So here my mass number is 40. That tells me I'm going to change my color up a little bit. So my top number is going to be a 40. My bottom number is going to be a 19. So I look for number 19 on the bottom because that's the one that tells me who you are. Number 19 is potassium. Okay. So atomic number is 40. Oh, no, it's not. What am I doing? Remember, atomic number and mass number are always the same. So this is going to be 19. Number of neutrons, mass number 40 minus 19 equals 21, right? And number of electrons, unless they tell you otherwise, it's neutral, okay? So if I said, oh, I met my friend Bob, and do you think Bob has one arm or two? Now that I've asked you, thought about it. But if I said I met my friend Bob has two arms, because if he wasn't, I'd say I met my one-armed friend Bob, right? So I have a one-armed friend named Bob. He is very fun and very nice, and everyone calls him One-Armed Bob, and he likes it. It makes him feel special. So number, and everyone knows who he is, super fun guy. Number of electrons, equals the number of protons. So again, we assume the charge is 0 unless something tells us otherwise. Number of protons and number of electrons are the same. That would be 0. You could do other things to make your life miserable, but we're not doing that. Tellurium is the next one. Te. So I'm looking for Te on the periodic table. Uh-oh. I'm having the dickens of the time finding tellurium. I'm pretty sure it's in the D block. Live theater, ain't nothing like it. Okay, so I'm having the hardest time finding tellurium. Oh, there it is, number 52. So tellurium, again, is number 52. Now, had I been thinking, the number of protons at 52 right here would have told me that faster. My mass number is this top number, 128. The atomic number is 52. Remember, atomic number and number of protons are exactly the same. Number of neutrons, remember, is mass, 128, minus protons, 52. And that's 76. And then number of electrons, uh-oh, I have a negative charge. So if I have a negative charge, people think, oh, I take protons minus 2. That's not true. So I'm going to give myself some space here. So imagine if I know I have 52 protons. If I have 52 protons and I have 50 electrons, do you see how I have 52 pluses and 50 minuses? That's going to give me plus 2. But I have minus 2. So then that means I have 52 protons. How do you know you have 52 protons? Boy, it says 52 protons right here. So that means I have to have 54 electrons, and that will give me minus 2. Well, how did I know that that was minus 2? It told me up top it's minus 2. That's my one-armed friend, Bob. Charge is minus 2. There you go. Best of luck to you. Ace that final, man. Ace that final. Toodles.